Now let's look at the C++ end of things. Essentially, the C++ program is used to interface with the Windows API. It's strictly a message forwarder since we can't actually access MIDI from Silverlight. The C++ program receives a message from the touch context and forwards them along as MIDI messages to the loopback device, which is connected to Mix. This function assembles and sends a MIDI short message from parameters specifying a MIDI out device, a status byte, a byte representing the MIDI channel being used, and 2 bytes of data whose content depends on what status code is used. Now, knowing what to feed this monster required some very detailed attention to the specifications on the MSDN's specifications for the MIDI APIs. Now, a bit of crazy casting magic was required to interpret double values from the Silverlight context, since the communication, as it is a very simple byte array communication line. Here we make sure that the value isn't over 119, which would be beyond what the MIDI standard allows. This bit of message parsing is a hack at best. I assigned all my control change IDs to be less than 60 and all my note on events, or toggle commands, to be over 60. So I kind of split the whole range in half. Now here we define our constants representing MIDI status bytes, which are pretty much kind of go look it up in a chart somewhere values. Another important function of the C++ code is what happens when it's closed. It is important to send a message back to the Silverlight context to let it shut down gracefully and let go of for example, the communication channel that we're using to communicate between the keyboard and touch contexts. Starting the Silverlight context in the adaptive keyboard from the C++ code is fairly straightforward and relies on code that was provided with the SDK from Microsoft. The MIDI out open function is a part of the Windows MIDI API and is used here to open a MIDI device to send messages to. A pointer to the device is stored in the outDev variable of the HMIDI out type. This type is defined automatically when the MIDI library is included in your code. It's worth noting here, it's probably a little bit of bad practice, but I was kind of in a rush, that it's probably not the best idea to simply just say open the first MIDI output device, because on systems with multiple output devices, you never know which channel the actual loopback MIDI device is going to be on. This C++ code was provided with the SDK and creates an adaptive context for use by the adaptive runtime based on an XAP file. An XAP file is just a compiled Silverlight application, which includes the user interface and the driving code. In this section, we implement the adaptive context provider in a form where basically we can process messages sent from the Silverlight context and forward them along to our MFC application, where we can process them and then forward the MIDI messages to Mix. Using the MIDI scripting engine in Mix was fairly painless. As I explained before, the MIDI learning wizard allowed me to quickly create a basic version of this XML file that I could expand upon. It maps the MIDI signals sent from the C++ code to actual functions within the software. The key values used were referenced on the Mix wiki. Basically, every function within the software that you can modify has a key value. You can also reference JavaScript functions to customize behaviors even further, but I didn't actually end up needing this. Okay, so compiling Mix, we have an error. By the way, that last part was played at 70 times normal speed. Takes quite a while. Basically, we just need to make mix.res from mix.rc. This is just a resource file that points to the icon for the program. The rc command is built into Windows, allows you to basically convert from rc to res. Scons keeps tracks, or scons. It's the building tool that the Mix project uses. It keeps track of the build process, so when we start it again, it starts right where we left off, and we can move on. Now, this just shows where the MIDI scripting, XML, and JavaScript files go in your Mix installation. By the way, this works whether or not you've built Mix from source. It's done entirely at runtime. And finally, here's a few pictures and a short demo of the project. I encourage you to look at my other blog posting that shows a bit more of it being actually used and a little bit of the event coverage. Had a lot of fun in New York City. I'd like to thank my sponsor, Matthew Dickinson, and Dale Musser, and Microsoft for sponsoring this project and providing the prototypes. I'd like to thank Nicholas Chen, the chair of the contest, for being so helpful during the development process. We only had 3 weeks, and he put together a few good examples, set up a wiki for us developers to communicate with, and generally made sure that the demo night went smoothly. I'll be posting a link to my source code for this project. I'll make it totally available, so if you want to take a look at it, how it all fits together, feel free. I'd just like to say that this was a really great experience. I actually didn't read about this until the day before applications were due, so I actually had a 3-week development period, just about, and it was a bit of a challenge working by myself, especially since I had never actually programmed anything major in Silverlight or C#, but it was a good challenge, it was a good learning experience, and I encourage anyone who's a student to work on projects like this. It was a lot of fun. I learned a lot. I met some really cool people at the symposium. The other teams were really amazing. We had people from all over the world, a lot of really, really great ideas. Had the opportunity to work with some technologies I'd never really worked with before. If you're interested in getting involved in some cool projects on campus, the RJI collaboration with the journalism school is December 8th, is when they're announcing what the projects are going to be. We have a couple really impressive corporate sponsors going to be there, so go take a look. This turned out to be a little longer than I expected, which is why I split it up into a demo and a development section, so thanks for listening.